Hello everyone and welcome back to PostNetwork Academy, your go-to place for a clear and engaging lessons in statistics, artificial intelligence, data science, machine learning and robotics. In today's video, we are diving into an essential concept in probability and statistics, moments specifically for the binomial distribution. Now, you might be asking, what exactly are moments? Simply put, moments are mathematical tools that help us understand key characteristics of a distribution, like its average behavior, how much it spreads out, and even how skewed or peaked it is. The first moment tells us the mean, the expected outcome. The second, central moment. Third and fourth describe skewness and kurtosis, which reflect the symmetry and the tidiness of the distribution. And all this becomes especially meaningful when applied to binomial distribution. So grab your notepad and let's begin with what are moments. So first of all, let us understand for binomial distribution. So let x, that is the following binomial distribution, and that is obviously a binomial random variable, and rth order moment about origin, that would be, you will denote mu r prime, and that would be expected value of rth x raised rth power, and that you will get x raised r into the distribution for the value of x, and summation from 0 to n. So that is rth order moment about origin. Now first moment, so we will use binomial probability mass function, that is n cx, where q is equal to 1 minus p. So if we substitute into the formula, so we will get x into the probability distribution expression. So let us start with 0. So one term we can, you can say that cancel out, that the value would be 0. So here we are going to use the identity here, and just we are going to apply it. So we will get mu1 outside n and this one. Now here we will take it out, np we will take it out, and that expression we are left with. Now let us put r is equal to x minus 1, so x would be r plus 1. Thereafter here np again outside, and this, observe this expression very carefully. So that will become this expression, the expression I was explaining. So p plus q raised n minus 1. So this value will become 1. So we are left with mu prime 1, that is np. So that means this is mean or average. So that would be np. So that is basically mean of the binomial distribution. Let us see the second moment, that would be x square and p probability distribution or mass function. That will start from 0. Now if we use binomial probability mass function. So you can see that mu2 prime, that is x square, and the probability distribution. Now we will use another expression, like instead of x we are going to use this formula, that is the key. So that is equal to basically x square, x minus 1 plus x, and that if you simplify, so that is x square plus x, and basically minus x and plus x. So I'm going to write x square minus x plus x. So you can see that that would be equal to x square. So instead of using x square, that's formula as expression we are going to use. Now just express it, and thereafter if you split into two parts, so this one we will get. Now you can see that if you use this identity, that would be equal to this part. So mu2 prime, that would be equal to, again this part is mu1 prime or mean. Now again we will put r is equal to x minus 2, so x is equal to r plus 2, and thereafter finally this expression will be equal to 1. So we will get here p square, we will take it out, that this one, and mu1 prime. So that is his second moment. So second moment will basically would be equal to n minus 1 p square and plus this one np. And what would be the variance? So variance is mu2 prime minus mu1 prime square. So let us plug all the values, and variance would be here np 1 minus p, and that would be equal to npq. So we will use this one. So that is variance. Now let us see the third moment about mean. So we'll start with this one. Here that would be x cube and probability distribution. Now we'll use another identity like this one. Instead of x cube, we will plug this one. That too is equal to x cube. So if you plug, so we will get this one, and let us distribute, and thereafter we will get three expressions, this one, and this one. That is again mean RNP. So let us solve like this one. If we use these identities, so we will get this one. Thereafter first sum becomes n minus n, n minus 2, and pq. The same way second one 3n n minus 1 p square, and third one np, that is mean. So if we combine all of them, so this one, this term, and this one, so mu 3 prime would be this expression, that is the third moment, but that is not skewness. So mean is np, variance is npq, third central moment we can express like this one. If we substitute, so mu3 we will get npq 1 minus 2p. Thereafter let us find out fourth raw moment. So mu prime x4, that is px equal. So we are going to use this identity or this expression for the x raised 4 to find out the fourth moment. So fourth moment, if we substitute all the values, so we will get. Now from binomial properties we know that np, that is mu1, mu2 npq, mu3 npq 1 minus 2p, and raw fourth moment, we will get this long expression. So if we simplify, so we will get this expression. Now let us see, let us understand skewness and kurtosis. So beta 1 coefficient, that is mu 3 square upon mu 2 cube, and finally that will become q minus p whole square upon npq, and gamma 1, that is kurtosis, and it is equal to under root beta 1. So we will get q minus p upon npq. You can also write like 1 minus p and minus p, that would be also equal to 1 minus 2p upon under root 2p q. So if p is equal to 1 upon 2, so there is no skewness. If p is less than 1 upon 2, so that would be negative skewness. P is greater than 1 upon 2, so positive skewness. And the same way gamma 1, beta 2 actually, so that would be equal to mu 4 upon mu 2 square, 3 plus 1 minus 6 pq upon npq, and basically excess kurtosis we used frequently. You will subtract b3 from beta 2, and that would be equal to 1 minus 6 pq upon npq. So let us see summary. So mean of binomial random variable, that is np, mu 2 npq, mu 3 npq 1 minus 2p, mu 4 npq 1 plus 3 n minus 2 pq. Skewness, that is gamma 1 q minus p upon npq. Gamma 2, that is kurtosis 1 minus 6 pq upon npq. And hope you understood all these concepts. For more resources, you can visit website www.postnetwork.co. You can support me on YouTube channel, Facebook page, LinkedIn page, and you can also visit GitHub repositories for code and programming related projects. So hope you understood. Thanks for watching the video.